Well, good morning, everyone. My name is Figura. I'm here to talk about the progress you've made in Direct3D since the last WineConf talk 3 years ago in 2019. As you can imagine, for 3 years, we've had a lot of progress. And I'd just like to, summarize and touch on some of the biggest new developments. Obviously, for a 30-minute talk, I can't talk about everything, so I'll just talk about the biggest things, and for everything else, you can refer to the change logs and the release notes. So just to give a bit of background about myself, I first joined the WineConf project a little over 5 years ago now, in early 2017. I was recruited by Codeweavers several months later. I've worked in a lot of different areas in wine, perhaps almost all of them by this point. I've spent a lot of time on multimedia and low-level I/O and plug-and-play. Those are some particular interests of mine, but since early 2019, I also spent a lot of time working on the Direct3D infrastructure. And earlier this year, longtime Direct3D maintainer Henri Verbeet passed on the role of maintainer to myself and Jan Sikorski, the latter of whom is unfortunately not available to make it to the conference. So, with that out of the way, let's talk about Direct3D. Oh. Yeah, this is how that works. So the biggest and most exciting thing we have to report is the existence of a new Vulkan-based renderer for Direct3D, all Direct3D versions, but right now basically just 10 and 11. This lives alongside the GL renderer that we've had a long time. We've spent some work separating the two and adding that infrastructure. In its current state, I think it works as well or better than the GL renderer for most programs at this point in time. So you can enable it and test it either by a registry key or by, we have now an environment variable that may be easier for some people to use. We had a code name for it, well, it's in development, so we called it Damavand. We still sometimes call that as a nickname. So if anyone has heard this name before and has been confused about what it means, it's just the Vulkan backend of WineD3D. There is no equivalent code name for the GL backend. It's just a Vulkan backend. We currently don't have 3D support for Direct3D 9 or 8 or anything lower than that. So in theory, you can run Direct3D 9 applications, and in practice, some actually do. One notable example of this is the Direct Show video renderer, which uses Direct3D 9. Will actually work with the Vulkan backend. I tested it recently. But the main reason that most Direct3D 9 or lower applications won't run is because we don't have a shader compiler for SM1, as Giovanni mentioned, and we also don't have a fixed function pipeline replacement. So there is in progress work to compile shader model 1 shaders to SpireV, which the Vulkan backend can consume, and the plan is also, once that's done, to implement a fixed function replacement using HLSL, which will also allow us to replace the by now rather complicated GLSL compiler, fixed function compiler. But on the other hand, given that Direct3D 9 support over OpenGL generally works pretty well, it's not been a huge priority thus far. It's one thing to note is that we use the VKD3D shader library, as Giovanni gave a great summary of that. We use that to compile shader model for bytecode to SpireV. So there's an optional out-of-tree dependency, although as of earlier this year, we bundled VKD3D shader with Wine. So And you can also build it independently if you want. So why did we develop this Vulkan backend? Well, it may seem very exciting, but we developed it out of necessity because OpenGL is abandoned both by Kronos and perhaps more importantly by Apple several years earlier. While there are certainly advantages to Vulkan's API design, the way it allows finer grained control over the hardware, that would probably have resulted in us writing a Vulkan backend eventually. But there are advantages and disadvantages to Vulkan, and one of the biggest disadvantages is the amount of time it took to write this Vulkan backend. And so I would like to take some time to talk about both of these. So the Vulkan renderer is capable of a few things that are currently unimplemented in GL. Some of these things are difficult to implement. Some of them are missing from the GL specification. But most of the things are not really impossible to implement in GL. Or, big new features. There's no, so some of the big new features in Vulkan are support for mesh shaders and ray tracing that is not in GL and probably never will be. But those are not things that Direct3D 11 or lower uses, only Direct3D 12 and up. So most of the things that tend to work better in Vulkan are, inconsistencies or poor design to GL spec, and I'm not going to get into examples because that would be very technical. But there are certainly some games that work and render correctly with the Vulkan renderer and don't work with the GL renderer, which is great news because they're fixed now. We don't have to fix the GL renderer, but we would also kind of like to fix the GL renderer because some of these, partly because some people are not capable of using a Vulkan renderer. Some people don't have working Vulkan drivers for one reason or another, and the hardware is capable of it, and we would still have liked to have these with GL. The other main benefit of the Vulkan backend that we've observed is that the performance is better. We have not really done a lot of effort to determine why in some cases, simply because we don't have that, time available to just do that testing. But I think the main reason is basically that we've just had time to put more work into Vulkan-specific optimizations. There are a lot of things that we could optimize in GL backend as well, but we haven't had that time to spend on it. And once the Vulkan backend works better, it's often better for us to just keep working on the Vulkan backend. Now, with the benefits out of the way, let's talk about the drawbacks. Well, so most of the drawbacks about Vulkan aren't related to the functionality because Vulkan is capable of doing everything that OpenGL can do on hardware which Vulkan supports. It's more, things about the Vulkan environment that are a problem. One thing is pipeline compilation is very expensive, so this causes notable stutter in application. You can mitigate this by writing in a disk cache, but this has a cost, which I think is often ignored in terms of disk space, in terms of startup costs. When you run it the first time, you still have to compile to populate the cache. And, like all things, it takes time and effort to develop, which we would like to be able to spend on other more important things. The fortunate thing about this is Vulkan is a mutable API, and there are some recent Vulkan extensions that will help address this in a more efficient manner that don't require cache. Another thing about Vulkan is that it's not universally supported, which is not necessarily a concern if there are working OpenGL drivers that can, cover the deficit. Excuse me. But on the other hand, there are also some basic features missing from OpenGL, and if we don't have a Vulkan driver either, we can't do anything about it. And, implementing a new GL extension is not really an option. In one particular instance, there's currently no free software driver for, well, when I wrote this talk, there is no free software driver for NVIDIA GPUs. There's recently an announcement of a NVK driver that uses some open firmware. Of course, this also only supports the very newest generation of NVIDIA GPUs, so it won't support anything lower than that. So anyone wanting to use Direct3D software on NVIDIA hardware who is unable for one reason or another to use NVIDIA's proprietary drivers will only be able to use the OpenGL backend. And I'd like to take a moment to address a related point. There are some people who have the impression that Wine's Direct3D implementation has or should have the primary or only purpose of supporting old hardware. There, on the other hand, other people who assert that, any translation layer should only support the most recent hardware and drivers, and often fail to realize how old of hardware is actually in use by people. We Wine Direct3D developers, we take the position that everyone's hardware is worth supporting. We're not going to customize newer hardware just to optimize support for older hardware, but we also aren't going to drop support for older hardware just to make it easier to support newer hardware. We're going to try to support everyone's hardware as best we can with the best performance and the best compatibility that we can. And anyway, perhaps the most important disadvantage from my perspective of developing the Vulkan renderer is that it took a lot of time and effort to develop. Vulkan is a completely different API than GL. It makes the application developer do a lot more things manually. It uses a binary shader format, which is a lot harder to write shaders in, which is especially a concern when we do have, complex high-level shaders we have to compile at runtime for things like the fixed function pipeline. We spent multiple years of time on the Vulkan backend, which we would like to have spent on other high priority tasks like improving Direct3D 11 support, improving performance, implementing the HLSL compiler. All these things basically had to get delayed. Vulkan is a huge improvement over OpenGL in terms of API cleanup, and I don't want to discount that entirely, but I think there's an associated cost with switching APIs like this that is often ignored or downplayed. So I just like to make that point. I'd like to stop here and ask for if there are any questions about the Vulkan backend before I get into all the other exciting news about Windy3D. And if not, we can always wait till the end to ask them too. All right, I'll just go on. Right, so besides the Vulkan backend, one of the biggest things that we've done in recent years is improving our performance very much. So the biggest item on this list by far is what I call map acceleration. So like most modern GPU drivers, we have what's called a command stream, where we basically take application D3D calls and we record them onto a list, and we have a separate thread that executes those so that the main thread isn't blocked actually processing the D3D commands. The main reason this is actually written is because OpenGL is not the most thread-friendly API, and it turns out that for various reasons we basically need to execute all GL calls on the same thread to do things correctly. But it also has the secondary benefit that performance can be a lot faster with certain applications. Unfortunately for us, this performance benefit that we were getting was often, nullified because a certain operation, resource mapping, where you take the image or a buffer on the GPU and access it directly in the CPU as if it were, or using CPU memory. Basically, you had to do most operations are asynchronous, but resource mapping is synchronous because you have to wait for a result from the CS thread. And that means we have to wait for all of the previous CS commands to finish. This has been the single biggest performance bottleneck in games, especially newer games like Direct3D 10 and 11. Earlier this year, we submitted patches that get rid of this bottleneck. So now most of the important maps will be asynchronous, and they will not have to wait for the command stream to finish. And as a result, there are a lot of games that are a lot closer to their Windows performance. So that's very exciting, I think. There's a lot of other things we've spent effort on performance-wise. I don't want to spend time listing them all, especially because some of them are very technical and a lot of them are very, game-specific. One of the things I would like to note is that we currently take a big windy 3D lock that around all operations, and we've started taking steps recently towards removing that lock. So we've removed it from deferred contexts, which are often used by multiple threads. And in the future, we would like to take more steps to break up that lock into more granular pieces. I don't need to talk much about the HLSL compiler because that was the subject of Giovanni's talk and he covered it in great detail. But I'd just like to give a quick summary. This is something that we have been working on largely over the past 3 years. We had a very basic parser implementation written in 2012, but it wasn't capable of generating any code. But we've wanted to, improve that for a long time, and now we have a HLSL compiler that can compile real shaders, and also cannot compile real shaders, other real shaders. So, a lot of exciting work done, and a lot of exciting work that's still to do. In the world of Direct3D 12, we've made some major strides since 2019. We have not had a lot of effort available to spend on Direct3D 12. But in the past years, we've had Connor McCarthy, who has helped to improve performance by rewriting the descriptor heap implementation. He's helped improve fence performance and compatibility by rewriting the fence implementation using a newer Vulkan extension, timeline semaphores. And we also have support for shader model 5.1, which was missing from the 1.2 release, and descriptor arrays. So there's games using those will now work. Currently, the biggest blocker for Direct3D 12 is we have no support for shader model 6, or DXIL, as it is alternatively called. It's a completely different binary format, but as Giovanni mentioned, we're excited to report that this is being worked on. We actually have a complete branch which can compile real shaders. Very exciting. And we hope to have the rest ready soon, or, some definition of soon. So apart from the functional changes and new features in the VKD3D library, so those have already largely been covered. I would like to share 2 other pieces of news, changes in the way we're doing that library. So the first thing we've changed is that as part of the PE conversion, you can the latest version of you can build VKD3D and all its libraries as in the PE format, and we do that for Wine, and we actually bundle the libraries with Wine. So you can now build Direct3D 12 capable Wine without needing to worry about external dependencies. but also if you would like to use external VKD3D, you can do that as well. The second piece of news I'd like to share is we've changed the release schedule. We did not have a stable release schedule prior due to low amount of available work, and we had a lot of difficult API design questions that went into, especially the shader API. And I think there's also a desire we had some features in the pipeline that we were hoping we'd be able to get into the 1.2 and 1.3 releases. So as a result of all that, 1.2 and 1.3 were very slow to be released. So we've changed that recently. We have a strict time-based release schedule like Wine. We release a minor version every 3 months. The month before release is designated a soft API freeze. So any new APIs or API changes should be ideally ready before the freeze ends. Sort of like a merge window. And anything new will be deferred until the next deferred from the freeze until the next merge window, as it were. And we also, freeze the implementation. So, as most projects do, so we make sure that the release is as stable as we can reasonably get it. And finally, I would just like to mention some of the other work that has gone into the general GPU acceleration subsystem outside of that are not Direct3D specific. So I think Alexander has already given a decent summary of how PE conversion and WoW64 support works. So most of that is finished, but one of the last and most difficult parts that we have not finished is the GPU libraries. There are two things that make the GPU difficult. So first of all, the list of functions in comparison to any other library is very, very large, because we basically need to thunk every GL, CL, Vulkan, etc. function directly. And also these lists, at least in the case of some APIs, are constantly changing as new extensions and Vulkan versions and CL versions are being added. So, and Vulkan especially has a very complex API surface with its chain structures and structure arrays. So there's a lot of work that goes into generating those thunks from an XML format. The other thing that makes these libraries difficult is that most of them involve, some sort of mapping a resource, which is something I sort of touched on earlier. And all of those resources return a pointer from the Unix side or from the 64-bit side, which in WoW64 means we are giving a 64-bit pointer to a 32-bit application, which won't know what to do with it. Fortunately, all of these APIs have are designed to be extensible, so we can introduce an extension and actually fix this problem that will allow us to specify where the pointer is placed and make sure it is a 32-bit pointer. So we have several people, including Jason Ekstrand and Derek Lisho, who are starting work on a Vulkan extension. We don't have any extension for GL or CL yet. We will need those. Another thing that that has happened in the past 3 years since 2019 is we have a bit better support for OpenCL. There is an OpenCL wrapper library on Windows. It's very rarely used, but it exists. And this was recently upgraded from 1.0 to 1.2. And we also support some extensions where we previously did not support any. We are still a long way from the current OpenCL 3.0. And there's a lot of extensions we don't support, partly because basically we don't support anything that involves sharing or anything that involves, anything extension that has its own function pointers. That takes a bit of extra work to generate. And finally, I'd just like to give a mention to the efforts of Liam Middlebrick and Georg Lehmann, who have been working tirelessly to keep our Vulkan wrappers up to date and implement support for more extensions. And that's all the news that I have time to share from Direct3D and GPU. So, if anyone have questions about, or anyone have questions about this presentation?
What's your roadmap? What's next?
So, yeah. So the question is, what is our roadmap? Which is a good question. So one of the things we'd like to do, so we'd like to finish the shader model 6 support, and we generally put more work into supporting newer features in Direct3D 12s, such as mesh shaders and ray tracing. We would like to get the Vulkan backend supporting Direct3D 1 through 9, DirectDraw, Direct3D 8, Direct3D 9. And this involves supporting more formats in the VKD3D shader library as well. Excuse me. We'd like to introduce more support in the HLSL compiler. We have a lot of work that's needs to be upstreamed and a lot more work that's yet to be done. We would like to keep working on improving Direct3D performance. I think our performance is a lot better, and in some cases reaches parity with Windows. But there's also many things that can still be improved. There are probably other things that are on our roadmap. Our roadmap is very, very long, but I think those are some of the things we would like to focus on in the near future. That's a good question. So the question is, will DXVK become obsolete due to improvement of WineD3D? That's a difficult question to answer, as I'm not a DXVK developer and I don't know their plans. I think in WineD3D we would like to do everything that DXVK does, which is, support Direct3D 10, 11, 9 applications over Vulkan, and we'd like to do it with the best performance that we can. So in that sense, the answer is yes, maybe. And in a sense, we would also like to support things that DXVK does not, such as mainly support for older GPUs, and older drivers, which is perhaps less important for some, but can be very important for others. Right, and older D3D versions are something we currently support that DXVK currently does not. So in a sense, we would like to do everything that DXVK does. It's not I don't think it's our intention to, make DXVK obsolete in any sense. We'd welcome DXVK as a part of the Wine ecosystem, but we both have the same goals, I think. Or perhaps well, I think we have a superset of DXVK goals. I think that's the thing. A lot of people say, wine is focused on correctness, DXVK is focused on performance, or wine is focused on older GPUs, DXVK is focused on newer GPUs, or wine is focused on applications, DXVK is focused on games, and and that's broadly not true. We're focused on everything, including that which DXVK is focused on. But that does mean that DXVK is putting more effort into some of those things than we are, but we still care about them. We want to implement them eventually. Yeah. I hope that's a reasonable or helpful answer to your question. Yes, Connor.
Has it been difficult maintaining two backends? Do they map well?
Yes, I think in a lot of. Oh, so yes. So the question is it difficult maintaining two backends, and do they map well? there are certainly some things that maintaining a GL backend makes difficult that would be less difficult if it was just Vulkan. I mean, I think threading is the big one because if we are forced to put everything on a command stream thread. But it's the tricky part is that a lot of the difficult problems we had to solve for OpenGL are also the exact way we want to structure things for Vulkan. Like we want a command stream thread for Vulkan anyway because of the performance part. We have context management. That's very, I guess it's very technical, but the broad answer is a lot of the problems we had to solve for OpenGL are ways the Vulkan render is it fits well into that design. So
That's also quite useful to second implementation. You can
yes, absolutely. So Henri said it's very useful to have a second implementation we can compare with, and that is actually a very true thing. It's great to be able to run a program in with both backends, and if it works with one but not the other, well, there's something wrong in a GL code or there's something wrong in a Vulkan code, which is I think one of the biggest reasons that I would really like to get the Vulkan renderer working for Direct3D 1 to 9. There are things I say, well, is this a GL specific problem or is this a problem with the common code, and so on.
More questions? Everyone's aware that there's donuts out there and they're thinking about that. Although the donuts might be gone, so you may be too late.
Yes.
You mentioned there's no free NVIDIA driver. Do you know if Nuvo's working on support?
So from what I hear, I've heard at this conference that they have NVIDIA, the company, released a driver for very new GPUs that is open source, and the Nouveau or Mesa project seems, as far as I understand, is going to write a Vulkan driver that utilizes that code or is based on that code. I do not know if the Nouveau project is working on a Vulkan driver for older GPUs. So that I've not had. I only just learned about the Vulkan driver. It's only newer, so there's no plan to support older GPUs. Not right now. Okay, yeah, there may be a plan to support older GPUs in the future, but that's we have to work with what we have. Oh yeah, Hugh.
You have a lot of stuff implemented that isn't upstream. How much is a lot?
The comment is okay. The question is, I have a lot implemented that's not upstream. How much? I think that comment was about the HLSL compiler, and it's. I'd probably say I have on the order of 50 to 100 patches, which is kind of a lot. There's some reasons. There are a few reasons why that didn't get upstream quicker. Partly, we had some trouble We had some trouble figuring out a reasonable review process for patches from 3 different people to the exact same area, which is not the kind of thing that usually happens in Wine. And there was also, because we were in the early stages of the HLSL compiler, there were a lot of design decisions that, things we ended up wanting to change that we wanted to get in first. I don't think I have, in terms of core Wine3D, I don't think there's a lot of patches that we have that aren't upstream. There are some performance improvements. A lot of those are kind of guesses, or we don't really know if they're improving anything, and a lot of them need to be cleaned up. But we do have a lot of those upstream already.
Any more questions? Thanks, Ev.
Thank you.